Welcome to this section on validation and testing. We've come back to the multi-class classification to see how the training set and the validation set behaved. We saw clearly from here that this loss didn't go below the value, say 0.80, even after 20,000 epochs. So it's clear that our model isn't overfitting, and this is most probably a problem of underfitting. And then when we moved on to this artificial neural network, we're able to achieve a loss of 0.09, but that was on the whole data set. Let's break this data set into the training set and validation set and see exactly how it be. Now we break our data set into X train, which is basically X. That's the first 10,000 data points. And then we have Y train. We have Y val, X val, the between 10,000 and 16,000 data points. So here we have 6,000 data points. And then the last 4,000 data points will be used for testing. So with this, we could modify this fit function to take X train, Y train, X val, Y val. There we go. This losses will take the val losses. So let's go straight away into the fit method and modify this X val, Y val. Right here we have val losses, and then we collect the output by having this output val. So we have output val, which is gotten by forward of X val. Since this output has two values, the other value is not needed. Now from this we could calculate the loss, and there we have the loss val, we'll call it loss val, which is equals self.loss of output val and Y val. So this is our target Y val, and this is our predicted Y val, which we pass into this loss function. From this, we simply have losses or val losses that append loss val. So we come back here, we have loss val initialized to 0.0 for every epoch. And then we return not only losses but val losses. So we could run this, we have no error, come down, and then we run now this. All right, now we've forgotten to plot this out, so let's plot this. So we have here CCE for the train, and then take this off, copy this too. Anyway, let's just, since we're doing it on one plot, we could just do it simply. So we have this plot, then we have val losses. So we've done that already, since we collected val losses from here. And then we could change the color. So take this color to be, say, red. We'll run this. Now we have an error. We are setting an array element with a sequence. So let's check where we had this error, what was bringing up this error. We have val losses. Let's go back to val losses. Looking at val losses again, if we check it out, well, the BCE loss actually has two outputs. So we need to take not just this, so we need to select, that's the first, because here we have the loss actually, and then here we have the difference between the target and the predicted output. So this is what we're supposed to get here. With this, we'll run this, and after running, this is what we get. So after running, we have the training and the validation. So now let's take this to, say, 20,000 epochs. After running for 20,000 epochs, we have the loss 0.09, we notice also that the validation loss is just above the training loss, because here we have the training loss which was given here. Now let's give the value for, let's print out the validation loss. That's the last validation loss, so we'll take this -1, whereas here we had this. Okay, now we could plot this but from 1,000 epochs to 20,000 epochs, so that we could appreciate the difference in loss between the validation set and the training set. So doing this from 1,000 to the end, 1,000 instead of just 0 to 20,000 running, we have this. We'll see clearly how our model does better on the training set as compared to the validation set. But as we increase the number of epochs, this validation set loss doesn't get to increase. So here we don't have an overfit situation. And simply increasing the number of epochs could make us get better results for both the training and the validation sets. So we shall just simply keep on training and squeezing out as much as we can from our model. Now looking back at the evaluation where we had this training accuracy of 16 after training for, it was about 10 epochs. Now we run this, we have this error. Modify this to X train, Y train, we run it. Oh, this was just to notify that we had to add the loss, the validation loss in this bar. Anyway, we're gonna get back to that. So let's run this, and we have now an accuracy of 98% for the training set, and then we could print out for the validation set. So we have here validation accuracy. So we have this, and there we go. So for the training we have 98%, and then the validation we have close to 92%. And looking at this, as we saw, we could increase, or we could keep on training, or slightly increase the number or the complexity of our model. So we could take here, for example, 500, here 500, or just simply increase the number of epochs. Now we don't want to reconstruct our model, so we could just simply run from this. So we could run, say, let's take an example of, say, 10 epochs. So we're running from this point. You will find that we're just gonna continue from this loss and not actually restart from the beginning. So that's it. We have this. Okay. Now another point we want to add is we want not only the loss of the training set to be shown, but also that of the validation set. So at the level of this definitions, we could simply add this. We have this. So let's say val loss. We have val loss, or loss is actually loss val, and then we run this. We'll run this. Now here we didn't notice any change because actually this is in the model class, so we need to reconstruct our model class. That said, we take this away, we restart, we run this, and we'll see how the loss of the training loss and the validation loss have been displayed when doing the training. And that's it for this section. We've seen how to break our data set into the training, validation, and test set. And after evaluating on the training and validation set, it's clear that our model doesn't overfit. It actually does quite well, although it could be ameliorated by increasing the number of epochs, or just playing around by increasing the number of neurons found in each hidden unit, say from 300 to 500. So we could do something like this.